But do you see any problem here? I think if you closely observe this, this is one layer. This is the first layer of abstraction, second layer of abstraction, third layer you see the concrete implementations, right? Now, tomorrow let us assume there are two behaviors, swim and fly. So let us say one bird can swim, some birds can swim and some birds can fly. Let us say some bird can swim and some birds cannot fly. Some birds cannot swim but some birds can fly. So both cannot swim and both cannot fly. So if you see these combinations, in some, let us say tomorrow, if you are implementing one more method, which is let us say some birds, let us take an example of some swan or something. Swan actually can swim as well as it can fly. So basically it needs to extend from both these things, right? It needs to extend from both these things, right? So we cannot extend from both these things because abstract class means you cannot inherit from multiple abstract classes, right? So you cannot keep on implementing different sets of behavior or different probabilities or different combinations. You cannot keep on increasing this particular flow. As a result, it will keep on increasing right? So it's not betterly maintainable. Okay, so that is a problem. So to avoid this scenario, we are going to, so we are solving this problem in interface segregation principle. Okay. So what we will do is, so interface, so we will define flyable, these are interfaces, and swimmable, and here we will put the bird method. This is an abstract class. Here we have color, color, height. These are some properties and these are some methods. Okay. Now, so now basically we have something called parrot here, parrot, penguin, let us say swan. So not fly. Here basically we will implement something called so here it will be fly. Here we will be having fly. Here we will be having swim. Here we will be having something called some common behavior called walk. So on an interface level, we have identified the types flyable and swimmable. On an abstract level, we identified the common behavior which is common across for all the boards. So because for abstract class we can only implement the common behavior. We cannot do that with interfaces, right? So abstract class is a combination of abstract plus non-abstract methods. So you can make use of non-abstract methods as well as whichever you want to be forced in the child classes, you can define as a non-abstract or concrete methods, because this is a partially implemented class. This flexibility you will not get with Interfaces are only meant for defining the types. So now coming to this penguin extends from bird and implements from swimmable. Got it? Parrot now extends from bird and implements flyable. Okay. Now swan, let us say swan extends from bird again, and this can fly as well as swim. Assume this can fly as well as swim. In that case, what it will do is it will implement from these both interfaces, because multiple inheritance is possible, right? So on the top level it will try to implement from the multiple inheritance. So this is how we solve the problem using the interface segregation principle. Now there is one more problem. If you identify, if you see, there is a fly method. Let us assume this is an sparrow and this is eagle, and this is eagle. Okay, and this is swan. This can fly as well as swim. If you see, for sparrow and eagle, the fly method is common. Okay, but there could be some scenarios where you have different behaviors, right? For example, sparrow can have flapping behavior, and eagle can have gliding behavior. So sparrow can have one style of flying and eagle can have one style of flying, but here you are saying you are implementing a fly method which is common for sparrow and eagle. You are basically duplicating it. You need to again define one more layer of abstraction to solve this problem. So here you are duplicating these fly methods. You are saying fly as a generic, but it will not apply, right? These two birds can have different behavior. So in order to solve that problem, we are going with dependency inversion principle. And there is one more important thing which I will tell you. Now let us define all the levels of abstraction. Okay, this is flyable. So these are interfaces. Okay, we have something called fly method, and we have one more interface called flying behavior. Let us assume this has some fly B. Okay, now one more we have is swimmable and swim. Now within this flying behavior you have again two layers of abstraction. Okay, it's nothing but we are basically abstracting it into different layers. Whenever we got the problem, right, we are basically dissolving it into different layers of abstraction. Okay, segregating. Okay, so this is basically flapping, this is basically gliding. So here you have fly and here you have fly. So these are abstractions. Along with this, you also have bird method, right? Sorry, bird class, which we already discussed before. So that is already there. Okay. Now now these so these are the layers of abstraction, and for the eagle and for the sparrow, you will take, you will, for eagle basically you will take fly from here, and for sparrow you will take fly from here. So these two you will take from here, but you are not extending it from here. Okay, this is very important. See, you are not extending it from here. If you are extending it from here, you cannot resolve, you basically need to resolve these dependencies on the runtime. You cannot simply extend it and implement these fly methods. Okay, you need to basically decide it during the runtime. So that is where the dependency injection comes into the picture. Dependency injection is nothing but the dependencies which are dependent on if you say A is dependent on B. So just remove these arrows to remove confusing. If I am saying A is dependent on B, basically you need to define the dependencies of A. Sorry, A is dependent on B, you need to first define the B dependencies, right? So you need to somehow inject the B. So in the same level, what you will do is, from the main class, from the client class, whenever you are passing, you will pass this flying behavior, and you will pass this flapping or gliding types as a subtypes, and from that you will try to access these things. Okay, so you are injecting it in the constructor basically. So within the for the constructor only, you are basically passing this, you are defining this flying behavior as a base behavior, and to this flying behavior you are passing these two subtypes. Instead of sending this flyable, you are basically saying the flying behavior for the method argument, and within the constructor you are passing these subtypes, and accordingly you are resolving there. So that is nothing but the dependency injection principle or the dependency inversion principle. So I hope you enjoyed this video. Please do like and subscribe for more such informative content. Yeah, thank you for watching the video.